So hello and welcome to the tutorial on building a stock price prediction model using LSTM in Python. So today we are going to dive deep into the world of algorithmic trading and see how we can use the power of deep learning to predict stock prices. So we'll start by fetching the historical stock prices data from Yahoo Finance, and we'll pre-process it for our model to build the LSTM neural network, and then finally we'll test its performance. So here we'll focus on the stock called as Apple, right? So let's first fetch our data by using Yahoo Finance library. We'll fetch the data from January, let's say 2010 to January 2020. So we are interested here in the closing prices, as they often serve as the basis for the stock price prediction model. So let's fetch our data. Data is equal to first, by the way, first we need to import the libraries, right? First we need to import the libraries before fetching the data. So we'll import Yahoo Finance as YF, let's say. So this will import the Yahoo Finance library. Then after this we'll import from sklearn dot pre-processing import mean max scaler, right? So this will be used to scale our stock prices. And after that we'll be importing train test split for splitting the data into training and testing. So from sklearn dot model selection import train test split. Then we'll import numpy as np. Right. Then we will import sequential from Keras to build the sequential neural network from Keras dot sequential. Keras dot models. Import sequential. Then we'll finally import the layers. We want to have LSTM and dense layers, so we'll import from Keras dot layers. Import LSTM comma dense, right? So these are the required libraries. Now we'll start fetching our data from Yahoo Finance, right? So data is equal to YF Yahoo Finance download. We want to download the data of Apple. The symbol for Apple is, or ticker, Apple ticker is AAPL, right? And the start date we'll mention here. Start is equal to, we want from 2010, let's say 2010 1 that is 1st January 2010 we want, right? And then we'll mention the end date, which is equal to, again, let's say 2020 01 that is 1st January 2020. So this will import the data. Let's check. Yes, data is imported in data, right? So now after this we'll take the closing prices. Now this data contains, now if you look at the data, it looks like this. it contains a lot of things, date. This data is a data frame which contains date, opening price of the stock, a high made by the stock, low made by the stock, closing price of the stock, right? Then other things like adjusted close and volume, right? What was the trading, what was the volume that day in that stock, right? So these are various things in this data frame, but we are not interested in all of that. We are interested only in closing prices of the stock, right? Only in closing prices. So we'll have only closing prices. So data is equal to, from the above data frame, I'll select only close column, data of close dot values dot reshape -1 to 1, right? So what this is doing, actually we are selecting the column. It will be a pandas series, right? Pandas series. That series we are selecting the values, right? Values from that. This values will convert in that series into the NumPy array, and this reshape will convert it into a two-dimensional NumPy array. So two-dimensional NumPy array will have, right? So why two-dimensional? Because many models require the input to be in 2 dimensions. So this -1 makes sure that the number of rows in the 2D will be calculated automatically, and this 1 indicates that we want to have only one column. So if I run this, and now if we see data, you'll be able to see data like this, right? You see this is a 2D NumPy array now. You see 2D. Why? Because this is one bracket, this is second bracket, right? So, and closing is also like this. That means this array, this is this array, this outer array contains 1D arrays inside it, right? So this is 1D array, this is 1D array, so it's a 2D array. So this statement converted the pandas series into a 2D NumPy array, right? Okay, so let me show you the slide if I have. Yeah, here, right? So now, for example, suppose just to illustrate what this statement is doing, suppose data is a data frame that contains daily stock market information, including open, high, close, low prices, close prices, and volume. So here is the simplified representation of the data. So here is date, open, high, low, close, and volume. So here converting to a NumPy array, dot values. This is dot values. Here, this dot values. This part converts the closed column, which is a pandas series, right, into a NumPy array. So the NumPy arrays are more convenient format for numerical operations and are widely used in data processing and machine learning tasks. That's why we will convert it into NumPy arrays. So this reshape -1, 1 will reshape the array into a two-dimensional format. So the -1 tells NumPy to automatically calculate the number of rows based on the length of the array, and 1 indicates that we want to have only one column. So for example, let's say this is the 1D array before reshaping. So after reshaping, it becomes like this, so each value here has become one row, right? So this is first row, so this is second row. So these number of rows are automatically calculated because of this -1, right? And one, we want to have only one column here, right? So that's what this reshape. Now why reshape? The reason for reshaping the array into 2 dimensions is that many machine learning models in libraries like scikit-learn or Keras expect input features in the form of 2D array, right? So that's why we want it into 2D format. So in the summary, so this statement, data is equal to data close dot values dot reshape -1 transforms the data frame column into a format that's suitable for use as input to many machine learning models, particularly for the tasks like regression or the time series forecasting. So our data which we have is a time series data. It's a continuous data. Now after that, after having this or downloading the data and reshaping it into the format we need. So this format is a two-dimensional array where each row represents the different day, right? Each day is representing the different day, right? Then we'll go for data normalization, right? So we will normalize the data using the mean max scalar from scikit-learn. So this is important as it will help our LSTM model to learn more efficiently by scaling the stock prices to a range between 0 and 1, right? So let's use the scalar, mean max scalar, right? So we're creating the object of mean max scalar. So scalar, this variable scalar is an object of this mean max scalar. It will run this. And then we have scaled data like data scaled. Is equal to scalar dot fit transform. So we are passing our data to this scalar, right? Scalar dot fit transform function. So this fit transform function will convert or scale our data in the range 0 to 1. Now let's see an example of this scaling, right? So let's say we have an array of Apple's closing stock prices over the 5 days, right? So these are the closing prices of Apple, right? Now the minimum price here you can see is 149 and the maximum price you can see here is 160, right? So we want to scale these prices so that the smallest value becomes 0. Smallest value in this array will become 0. And the largest value, which is 160, will become 1. And all other values are transformed to be within the 0 to 1 range, right? So this all other values will be within the 0 to 1 range. For example, this 150 will be scaled to 0.091. I'm sorry. This 153 will be scaled to 0.364 and 149 will be scaled to 0, and which is the smallest value or minimum price, and 160 will be scaled to 1, which is the maximum price, right? And 155 will be scaled to 0.54. So so data scaled will be like this, right? So that's the use of mean max scalar, right? So LSTM requires a now LSTM will require the the sequence of data to predict the future values, right? So we'll create the sequences of the data, which will represent the closing prices for the past 5 days, right? For example, to predict the next day's price, right? So let's do this. So we'll create these sequences of 5 days each, right? 5 days closing prices, right? So let's create the variable like a step is equal to 5. Then we have x comma y is equal to then we'll take two arrays, x and y. In x we'll be storing the input and y will be storing the output, right? So here for I in range step comma length of data scaled. So this data scaled, is the data is the 2D array which is containing the scaled data, right, or preprocessed data. So I will vary in the range from step which is 5, why 5, because we want previous 5 days data, right, and starting from 5 we'll go till the length of this data frame, this 2D array. So then we'll say x dot append data scaled comma where I minus a step, right. So this will, I minus step means if I is 5, if step is 5 and I is varying from, let's say, 0 to, or so data scaled I minus step to I, right, comma 0, right. So what this will do, this will create a slice of 5 days of closing stock prices from data scale, right. 5 days closing stock prices from data scale will be taken, and those will be put in the array X, right. So let me show you the presentation for this. Okay, I don't have this slide, I guess. Oh yeah. So here, we'll construct X using the X dot append, right? X dot append data scaled minus data scaled of I minus step to I comma 0. So each element in X will be the sequence of look back or step past 3 days prices. So in the first iteration, data scaled will be from 0 to 3, right? 0 to 3. So 0 to 3, which is 0 0.1, 0 0.2, 0 0.3, that is from first day to third day, from first day to third day. So the X will be like this, X will be like this, right. Then again, as our I keep on moving, right, I will be moving from step is 5 here, right. So initially I will be 5. So when I is 5, we'll take the slice of from 0 to 4, right, 0 to 4, that is first 5 days, right. When I goes to 6, right, we'll be taking the slice from 1 to 5, sorry, 1 to 1 to 5, that is 5 days, next 5 days data. When I goes to let's say 7, so this will be taking the slice from 2 to 6, that is next 5 days data, and we'll be appending it to array X, right. So that's why that's how array X contains the sequences of 5 days data each, right. Then we will have Y, which will contain the predicted next day price, right. For example, starting from 5, right, when I is 5, Y will contain the 5th day price of the stock, data scaled of I comma 0, right. And then we'll have finally X comma Y as np dot array X comma np dot array Y. So we are converting this X and Y into numpy arrays. Okay, so finally, if you see after, let's say our step size is 3 here, for example, for simplicity. So I will be 3 to begin with. I will be 3 to begin with. So data scaled will be when we take the slice for the first time, we'll take the first 3 days closing stock prices like this, right? So this will be our x, right? This will be our x in the first iteration. In the next iteration, that means in the for loop, right? Will be in the for loop, right? After taking the first slide and appending it to x, we'll again go up and increment our I. Our I will become here it will become 6, but in the example which we are seeing here, it will become 4, right? So I is 4. When I is 4, we'll take this slice from that is second day's data till the fourth day data, right? So and then we'll attach this to x. We'll append this to x. X was already this much. So now after appending this is how our x will look like, right? Then in the next iteration, I will become 5, and we'll take the slice from 3 to 5. So we will have this these stock prices from third day to fifth day, and that's how our x will look like, right? So then after sixth iteration, fourth iteration, fifth iteration, and this is how our x will look like. So, if you see, x contains the sequences, right? So this is the sequence of 3 days closing stock prices of Apple. This is the next sequence of 3 days closing stock prices of Apple. So finally, this is our x, right? This is our x, right? So this is data from day 1 to day 3. This is closing stock prices from day 2 to day 4. And this is the array containing closing stock prices from day 2 to day 4, so on and so forth, right? So that's what the purpose of this loop is, right? To create that x and y will contain the, right? If x contains these 3 days closing prices, then y will contain the fourth day closing price, right? Right. So y will contain. So we will train our model telling that if these are the previous 3 days closing prices, so what will be the fourth day closing price, right? So we are telling to our LSTM, right? So that's called training. In training, we will do that, right? So we have x and y. X will contain the closing prices of first 3 days, and y contains the closing price of next day, right? Okay, so now each sequence in x will be used to predict the corresponding value in y. So this will form our data set for the training and testing purpose, right? So now we'll split our data into training and testing, training and test sets with 80% for the training and 20% for the testing, right? So we'll do that. X train, comma, x test, comma, y train, comma, y test equal to train, test, split. So then in train test list, we'll pass x, comma, y, comma, test size will be 0.2. That means 20% will be considered for testing, and then we'll have shuffle is equal to false. Shuffle is equal to, meaning that we'll it is really important for us that we should not shuffle the time series data during this step. That's why we are keeping shuffle is equal to false. Let's see whether we get, yeah. So our data is now divided into training and testing. Now let's build our LSTM model, right? We'll use Keras to create a sequential model with the LSTM and the dense layers, right? So model is equal to sequential, right? So then we will have model dot add. So what this actually does, this creates the container, and this container will add the layers. We'll keep on adding the layers, right? So here I am adding the first layer. So the first layer will be LSTM layer, which will contain 50 neurons, let's say, right? And then a return sequence is equal to false, comma input shape is equal to step size, right? Step comma 1. So this is the shape of the input data. Then we'll have a model dot add dense layer, we'll add, right? Then we'll compile our model, right? So our LSTM layers contain 50 neurons, and the dense layer, which happens to be output layer also, it contains only 1 neuron. Model dot add, model dot compile. Then optimizer, which we'll be using here, will be Adam, and the loss function is mean squared loss or mean squared error. Okay, so let me execute this. Oh, so compile attribute, compile spelling, compile, right? COMPILE. Yeah. So our model has 50 LSTM units and 1 output neuron in the dense layer. So the model here, we have compiled the model with the Adam optimizer, and the loss function is mean squared error, right? Now let's train our model, right? We'll train it for 50 epochs with the batch size of 32, right? Let's say model dot fit, that is for training, fit is used for training, xtrain comma ytrain comma epochs is equal to 50, batch size is equal to 32, right? And verbose is equal to 1, right? So this is how we will train our model. See, the model is getting trained. Yeah, our model is trained now. So after training the model, we'll use our model to make the predictions on the test set, right? So let's use those prediction for test set. So predicted prices is equal to model dot predict test, right? Then predicted underscore price is equal to model scalar dot. Now why we are doing this? Our prices will be, this predicted prices will be in the scale of 0 to 1. Now we want to have our actual prices, because we had scaled our data by using mean max scalar to for in the range 0 to 1. Now we want to scale that prices back to the original prices, right? So we'll use scalar dot inverse underscore transform, right? Transform, and to that we'll pass the predicted price, and then reshape -1, comma 1, right? Yeah, and then we'll have the actual price is equal to scalar dot inverse transform y test dot so we are transforming back the prices to the actual prices. Let's execute this. So this is how we got the predicted prices, right? So now after after having these predicted prices, now we'll employ the trading strategy, right? The trading strategy here will be like we'll take a position if the today's closing price is less than the tomorrow's predicted price. So what we are going to predict here, what we are going to do, we are predicting here tomorrow's price, right? We are predicting here tomorrow's price, right? Now if the today's closing price is less than the tomorrow's predicted price, we'll take a long position. That means we'll buy a stock. And if the today's now if that is not the case, that means if today's closing price is greater than the tomorrow's closing price, which will be predicted, right? In that case we'll take a short position. That means we'll sell the stock, right? So we'll take the trading strategy. Position is equal to 1 means we'll buy if predicted price of the stock here. We should have put this in the okay, we'll predicted price of I, right? Predicted price of stock I is greater than the actual price, right? If the predicted price is greater than the actual price, actual price of I minus 1, right? That means the previous day's price, right? Previous day's price, price of the stock. That means today's price of the stock, right? Else 0 for I in the range 1 comma length of predicted price, right? Length of predicted price. So here what we are doing, we are taking a position, we are buying the stock if the tomorrow's price, which is the predicted price, is greater than the today's price, right? So then returns, we are calculating the returns given by the stock. Returns is equal to actual price of the stock I minus the price, actual price of the stock I minus actual price of I minus 1, right? That means previous day, right? Previous day, I minus 1 means previous day. If position of I minus 1 is equal to, if we have taken the position, and else 0 for I in range 1 comma length of actual price. So here we are calculating the returns given by the stock. So let's execute this. So actual price is not defined. Sorry, here it was actual price, actual price it has to be. So range, yeah, name positions, position, right? It's position. Yeah, and done, right? And then we'll print the total returns. Print F total returns, and here np dot sum returns is containing the returns given by the stock returns, right? So we'll sum those returns and we'll print. So total returns given by the stocks are 15.81, right? So this is actually a trading strategy here, right? Whether how we'll take a position, right? We'll take a position if the price of the stock tomorrow will be greater than the price of the stock today, right? So we are taking a buy position. So and then we are calculating the total returns. So this is this was the project on you know uh, predicting the stock prices and implementing the simple trading strategy based on these predictions. So thank you for watching this video.